Okay, we're back now to talk about what a haplotype network is. So you have a haplotype network in figure 2, in which they are showing you um, the DNA sequences, right, the different sequences that correspond to individuals found on Torishima, on Senkaku, and from the archaeological site. So Torishima in white, basically unfilled circles. Senkaku, they only have this right here in clade 4.2, and then all the black ones are from the archaeological site, which means that they're the historical samples. Okay, so how did they get this diagram, which does not look a whole lot like a phylogenetic tree, which we are very familiar with? We will go back into PowerPoint where I've created a special diagram for you. So here what they've done is they've taken their DNA sequences, and on the top line you can see a DNA sequence running across here, and then the sequences below here, they're all different except for the first one below here. But you see that there are dots. So anytime there's a dot, that means that this sequence, sequence 1b, has exactly the same nucleotide at this position as the top sequence. Any sequence could be the top sequence. It doesn't matter. This one they are calling sequence 1a, and so then they've put sequence 1b and show that it is identical, right? So that's going to be their first haplotype. And in fact, as you go through here, you're going to see that there are 6 different haplotypes, right? So sequence 3 is different at this position A. It has an A instead of a T. Here it has a T instead of a G. Here we have a G instead of an A instead of a T. So this haplotype 2 is different at 4 sites from haplotype 1. And you keep going down through the rest of these to see how many differences there are. This is just a nice way of visualizing that emphasizes the differences by turning all the identical sites into dots. You'll also notice there are some dashes. So right here, the top sequence has a G, but haplotype 2 in sequence 3 has a dash, and then sequence 5, actually all the rest of them have a dash. That means there's an insertion or a deletion. Right? Your perspective, if you consider your original sequence to be sequence 1, you think that these sequences have a deletion. Or if you're looking at these sequences, then you would say that sequence 1 has an insertion. So we call them indels, an insertion or deletion. Okay, so now we're going to identify the different number of haplotypes, right? So I would drag this over and I'd say haplotype 1 here, haplotype 2 here, haplotype 3, and so on. Okay, so now what we're going to do to create our haplotype network is we're going to connect the haplotypes that have only one base pair difference. And so I've identified the ones that have only one base pair difference from each other, okay? I'm sort of ignoring haplotype 1 here. And I'm noticing that haplotype 3 and haplotype 4 have this one base pair difference right here, where haplotype 3 has a G and haplotype 4 has an A, the same as the first sequence. And so what I would do is I would say I'm going to connect haplotype 3 here with haplotype 4 here. I'm going to connect them with a connector piece, and then because I know that they only have one base pair difference, I'm going to put one slash mark across here. And then I want to remember what was different about them. So 3, haplotype 3 has a G at position 15, and haplotype 4 has an A at position 15. So I just put those notes next to them. Okay, so we're connecting all the haplotypes that have only one base pair difference, and now I can see that with respect to number 4, 2 has one base pair difference, right? So you can see that at position 22, haplotype 2 here has an A, and haplotype 4 has a C. So I'm going to put my haplotype 2 here, I'm going to connect it, and then I'm going to put in one hash mark showing that there's one base difference, and then I'm going to remind myself by putting a little notation here that haplotype 2 has an A at position 22, and then I'm going to move this over here to remind me that haplotype 4 has a C at 22. And this is where it gets a little bit tricky now. Okay, so I want to connect haplotypes that have 2 base pairs difference, moving up from 1 to 2. And so now I can see that if I'm looking at haplotype 6, there are 2 differences here from haplotype 4. Okay, so that means take haplotype 6 and connect it to haplotype 4. And I have a nice long line here that I can use to connect these guys. And I want to mark down that we have 2 base pair differences, so I put 2 hash marks to remind myself. Okay, so now is where it actually gets tricky. So give me a second here. We have this issue where we have another sequence. I would like to connect haplotype 2 with haplotype 3, but what I'm noticing is that we have every possible gametic type for these 2 sites. We have AA, we have AC, and we have GC. So if we had a GA sequence over here, right, a G at 15 and an A at 22, that would give us a full circle of all 4 possible types. This, if we were going to try to put this on a tree, right, we have a nice tree here, right, with this nice bifurcation. But what we've noticed is that if we put this other haplotype here and try to connect it to 2 and 3, well, then we have a diagram that is not bifurcating anymore. It doesn't just have a fork. Basically, it has a polytomy. So that's one reason why we're using a haplotype network and why people do use haplotype networks, because when you're looking at population level, this kind of recombination is present in the sequences, so you need to account for it. Okay, so I'm actually going to put a hypothesized haplotype here because I don't actually have anything that has a G at 15 and an A at 22. I know that such a thing should exist, and probably does in the population. It's just that I didn't sample it. Okay, so I put my connectors here, and I would put 1 hash mark for each one there. And it would look a little bit like this, where I would take this, move it over here, actually, and put that over there, and this one over here. And so now I can see that this hypothesized haplotype would be 1 base pair different from 2 and also 1 base pair different from haplotype 3. That is fantastic because we still have another haplotype we want to connect here, and that haplotype is number 5. So here we go with number 5. Number 5 is 2 base pairs different from this haplotype, right? So if you look at number 5, at position 15, it has a G, right, which is what this one has, and then at 22, it has an A. Perfect. But it does have 2 other differences. So we draw our line over and put our 2 other differences right here and here. And those 2 differences then are this C right over here on this far side and this T over here. So to get from haplotype, let's see, from haplotype 3 to haplotype 5, we would need the mutation of a C and a T, and then we also need the mutation of the C to A here, right? So C at 22 to A at 22. And that's how we get from 3 all the way to 5 as we go through this haplotype X. Okay, we're almost done building our diagram now. Okay, so we've got this nice circle here, and then we need to connect our last haplotype, which is number 1. And number 1 is way up here, right? Because number 1 is 4 mutations different from 2. And so if you look at number 1, haplotype 1, I can't move it, you can see that there's a difference here with an A to a, or a T to an A, G to a T, an A to a G, and a T to an A. And that's how we get from 1 to 2. Okay, so now we finished our haplotype network, right? And so all the circles are the same size, but that's not really what you're going to find in your population. Your population, you might find that actually it's not that you have one individual of each of these. In fact, you have 5 individuals of one, and so you need to make this circle bigger with respect to the number of individuals that have that haplotype. And so I've made a really big fat 1 here. And then also haplotype number 3, it turns out we have 3 of those. So we're going to make it just a little bit bigger, but not as big as 1, for instance. And you would go through and the software would do this for you, but this is how the software builds it up. Okay, and I think we're down to the end of that. Yep, so that's how you make a haplotype network that gets you to that figure in the Albatross paper, figure 2. Excellent. Thank you for enjoying the reading guides for the whole semester. This was your last one. See you in class.